So this little power inverter here is actually pushing this lamp, which has that bulb I think is starting to quit on me. It's never flickered like this before, even with this inverter. So I think I'm about to lose that, but that was a chintzy little Walmart LED bulb, and they're not the greatest things on earth. But it's pushing this right now, and what other loads do I have? I've got some chargers and things. The room is a mess. I had to move things away from over there so I could show this. It's pushing this, and this has a Sylvania bulb in it that's LED. And it's also pushing an iPod charger. That whole power center down there is actually operating. It's actually operating off that, so I can distribute the power as I please. And I have room for other outputs, not on this one, but this one is also tied into the battery, or soon will be. I've had it on there. This is 1500 watts, so even though your solar is only a low wattage, you can get bursts of high power out of your battery. It's just, do you want to use it all up in one shot and then have to charge it all day? You know, as your array grows, you'll be able to use these larger inverters more than just for a burst of power. But for now, what I use this basically for is I have a coffee maker and a few other things that require a bit more power. So when I have those, I switch the big one on and plug them in. And these can also be wired depending on the quality of your inverter and the risks you want to take. This is where it pays to know a little about electricity. These can be wired to push your house wiring. I actually have a transfer switch that connects to the lighting branches of the house, and I have run it. But for starters, this is all you need. You just need charge controller, inverter, little bit of cable, and a battery, and your solar panel. The whole thing, oh, let's see. Nowadays you can get an 80-watt panel probably right under $200. That's going to be the most expensive part of your startup. Is going to be that. You can get the charge controller for 30 bucks. You can get an inverter probably in the neighborhood of 20 to 30 bucks, a small one. Now they get expensive as you go up in power, and depending on the type of inverter, but for starters, 20 to 30 bucks. And then a few LED lamps. You know, you can get those Cree bulbs all day long for $9. $9 a piece. They'll run 25 years supposedly. I don't think they'll make it that far, but LEDs are a heck of a lot more reliable when they're driven properly than compact fluorescence or incandescence. Something else that you will want to have, and it's a great thing. Number one, you're going to need a volt-ohm meter if you're going to be wiring all this. It helps to know what your equipment is doing and why certain things may not be acting right. You'll want to be able to check your battery voltage, you know, occasionally. Make sure that you're not killing your battery or that your battery is not damaged. Voltage can tell you a lot depending on what it does when you load it up. The other thing, and this is a good thing to have with your startup when you first start using solar power, get you one of these. This is a kilowatt. What this meter does, you plug it into the socket of your inverter or the power strip off of your inverter, and you plug your loads into this. This tells you the volts that your system is running at. It tells you the amount of current you're drawing. More importantly, especially with inverters, it tells you how many watts you're drawing so that you're not overloading your inverter. They also work good on generators. It also tells you the frequency, you know, whether you're at 60 cycles or not, and it tells you the power factor, how efficient your load is operating, how much of the power that's coming out of your inverter is being delivered to that load. And you'll find that certain things, certain lights, certain machines are very, very efficient or not efficient with their use of power, and it changes depending on what you have plugged in. You want to get as close to 100% as you can, but nobody really can, you know. And with not with LED lights, but with compact fluorescence, it's pretty common to see them running right in the 60% range, somewhere around there. I've never been able to get a power factor higher than 60%. So at least with compact fluorescence. I can get it a little better with LEDs. LEDs are actually remarkably efficient. It's more of a resistive load than it is a inductive load, like the compact fluorescents. They have a small inverter inside there and a coil that drives the light, and that causes your power factor to go haywire. But that's about it. That's all you need to get started. And I'll show you the outside part in a little bit. It's still 5 a.m., so the sun is not up. But I have outside on a wooden rack, I have two 80-watt solar panels sitting out there. They take up a space of about 2 feet by probably close to 4 feet each. So I've got basically a 4 foot by 4 foot area covered with that. And that gives me a little bit. Like I said, I used to have more. I've actually got some amorphous panels laying around here that I used to use, and I'll probably be putting them back out when I get things put back together. But to start you off, that's about it. That's all you need. That'll get your lights working. When you start going full solar, one of the things you can do after you've got that initial setup in, about once a month, you can get 1 or 2 more panels and just tack them on. They just add up in parallel. One and then the next and then the next. So you can start with a very small setup, tack on a panel each month. Your amperage goes up, which makes your wattage go up. And by the time you get to about 500 watts, you start being able to run some pretty big stuff. I've actually, that little window unit over there, I've actually I've run that. I've run that on that blue inverter I showed you, and it'll run it. It'll run it for about 20-30 minutes on that battery I got, but that's not a very big battery. But it can carry it. It's just how long it takes to put the power back in. But as you start building up your panels, you always want to have more wattage coming in than going out, so that your batteries can charge while you're using things. But as your array starts growing out there and you start adding panels, you're going to find out that it doesn't take as long to charge your batteries. You're going to find out that you can run bigger loads without killing your battery during the day or at night. The other thing you're going to find out, once you get to about 10 amps or so, you'll know what amperage is if you put this together, because you're going to have to know all the techno jargon, and you'll learn it pretty quick. It's not that hard. Once you get to about maybe 3 panels, then it's time to add another battery in parallel and build up your battery bank. And the bigger your battery bank, the bigger your panels, the longer you can go. It's like I said, just with one battery and with maybe 1 or 2 panels, you know, you can run the heck out of lights. There's a lot of other things you can't, but lights are no problem. And that's about 30% of your electrical load right there on the grid. You take that off, your electric bill is going to drop, and you'd be surprised by how much it drops. People don't realize when they walk off and leave lights burning all the time, they consume quite a bit of power. Even though the wattage is low, it's the duration that they operate that adds up. So that taking all your lights and putting them on a common circuit, all your switch legs and everything, and putting them on that solar, that's going to help you. And then as your array grows, you can take other circuits and put them on the solar as well. You can start moving your branches, your circuits over, and putting them in their own box, and that way they're all off grid. Or you can make it hybrid, where it switches, like what I've done with the transfer switch. These lights, all these lights in the house, because they're all LED, I can run them with a small inverter, and they automatically switch when I plug the transfer switch in. So we can keep lights on out here, and we can run it through the night and part of the next day if we have no sun. And this is nothing that you couldn't do yourself. I mean, there's no huge technical know-how to it other than some basic electrical expertise, you know, and anybody can pick this skill up. But that's basically, you can get going in solar for less than $500. For less than $500, you can have the beginnings of your system in, and with off-the-shelf parts. If you have a Fry's or a Harbor Freight or even a Northern tool, it's a little more expensive there. Even Walmart's starting to carry stuff, you know. It's very simple to set up and very easy to do. If you have a closet, you can put all your control hardware in the closet and just bring the wires in. You know, just find a sunny spot in your yard that gets sun for 8 or 9 hours a day, you know, most of the day, and you can build your rack there and run your wires on in. And I'll show you in the next part. Actually, I'll show you in just a second. Once the sun gets up, I'll add the next segment to this, and I'll show you the actual panels I've got. Tell you a little bit about those. So anyway, see you in the next segment. Anyway, I don't know how good or bad this thing is actually operating or seeing this, because it's very bright out here, but we're not in full sun, and my charge controller actually went to bulk charging, which means we're getting plenty of power. It looks like we're about to get a storm, but these are the panels. Basically, that silver bordered panel was the one I started with, the very first crystalline solar panel I got. Both these panels are 80 watts. They were the first two. Actually, I got that one first, and then that one over there I got, it was the last one that I got in the series. I have a whole pile of amorphous panels as well, but this is pretty much the last part of the section. And what I did, and this is how I saved some money, this yellow cable coming out, okay, I took the two wire connectors from either panel and I brought them together, and I made I used a 15 amp outlet as the junction box, in the junction box, and this cord has a male end on it. And this is a number 12 cable. I didn't use the chintzy little number 14 or number 16 cable that you get at Wally World. That's a real heavy cable. A real heavy cable. And it just feeds in there and goes into the house, and that's where the charge controller is. And on that side there's also an extension cord plug type. This cord is made so that it can be used in the solar or in the generator, depending on what application. But it's also set up in such a way that it's hard to, you can't get it backwards or hook it into an outlet and burn your charge controller up. So that being said, I'll let y'all go now. I'm going back inside because it's hotter than blazes out here.